Hey everybody, welcome back. Guy called me up and wanted me to build him a set of stairs. So we're going to go over the process and how we lay that out and put that together. We're going to do this in a two-part video. The first part's going to talk about all the math and calculations that we need to figure out to how to build those steps to the right size and dimensions. And the second part is going to be the layout of the stringers and the assembly of the carriage. Let me turn this around and we'll take a look. So I drew some drawings for you. The total rise or set of stairs is going to be 66 3/4 inches. And the total run is going to be 77.5 inches. So the total rise, as you remember, goes from finished floor to finished floor, and the total run is a projection of the stair carriage from the wall out to where the stairs begin. This is a Bilco basement entry, so it's the entry that comes out from the outside down into your basement. It is made with 8-inch CMU foundation, so this wall right here and the well that the stairs are going into is made with 8-inch CMU foundation. The carriage that we're going to assemble is going to be 44 inches wide. The actual opening of the Bilco is 48, but I want a 2-inch projection on either side from my stringer, so we're going to make the carriage itself 44 inches. Now the carriage is going to be comprised of 2x12 SPF number 2 construction grade lumber. There's going to be 3 of them. They're going to be held together with cleat at the top and a cleat at the bottom. Now, this is a concrete floor, and this is concrete masonry units up here. I don't want my SPF in contact with that concrete, so the cleat that attaches at the top and the cleat that attaches at the bottom that holds the carriage together is going to be made with pressure treated 2x6s. So let's talk about the rise first. All right, total rise. So the total rise is 66 3/4, 66.75 inches. So I need to figure out how many sets of steps or unit rises I need to have in the total rise from finished floor to finished floor. So I like to use 7.5 as my starting point. So I'd like to have a 7.5 inch step if I could help it. So I take the total rise, I divide it by what I want the unit rise to be, and it turns out to be 8.9. Now I can't have 0.9 rises. I have to have a whole number here, so I can either round this down or round this up. If I round it down, this number is going to get considerably bigger. So I'm going to round that up, and that's going to get slightly smaller. So I'm going to round that up to 9 rises. So I've established now that I'm going to have 9 rises. So I take that 9 rises, I divide it back into my original total rise of 66 3/4, divided by 9 rises, and I find out each individual rise is going to be 7.416 inches per rise. So I take the 0.416 inches, I want to convert that back to a fraction. I times that by 16 to get 1/16 of an inch. That turns out to be 6.66 repeating 16ths, which rounds up to 7/16. So what I've established here is that my unit rise is going to be 7 7/16 inches tall. I turn that back to a decimal, it's 7.4375. So if you take a look at it, there's a cutaway of the stringer. Each one of these unit rises, and there'll be 9 of them, is going to be 7 7/16 inches tall. And 9 unit rises total. So that takes care of the unit rises. Now let's look at the unit run. All right, so the total run, the projection of the stair carriage coming off of the wall into the well. The stringers are going to have 8 unit runs. Now I can have either 8 unit runs or 9 unit runs. If I have 8 unit runs, my last run will be 1 rise down from the end of my stair carriage. And I like to do it that way because then I can cut down on the number. I can cut this down by 1 unit run. I'll still have my 9 rises, but I have 8 runs. That doesn't project quite out as far into the room, and I can make my tread cut, my run cut a little bit bigger. So what I want to do is I'm going to have 8 unit runs in this set of steps. So I take my total run, 77.5, I divide it by 8 runs, and I get 9.6875. Convert that back to a fraction by times it by 16, that's 11/16. So each one of my unit runs is going to be 9 11/16. There's my original decimal right there. Now I want to make sure that this method works, that this all works and everything meets code, so I'm going to use my 17 to 18 method. 17 to 18 method says that the rise plus the run has to fall between, the combination of rise and run has to fall between 17 and 18 inches. So I take my unit rise, I take my unit run, I add those 2 numbers together, and I see that number together, they work out to 17 1/8 inches. Now it falls inside that range, and I meet my code requirements. So if you take a look at the cutaway, there's the unit run, 9 11/16. The unit rise will be 7 7/16. I'll have 8 unit runs and 9 rises when the whole set's together. Now, when this thing comes together, it's going to create an incline angle, and we want our incline angle to always be between 34 and 38 degrees. So how do you figure out the incline angle? Not many people ever figure out the incline angle. So if you look at this and turn this into a right triangle, we have a right triangle here. We have a right triangle right here established. What is this incline angle going to be right here? So how do we figure that out? Well, I know my rise. You have a right triangle, you have an A side, a B side, and a C side. I know my rise, and I know my run. I don't know my hypotenuse. I could find that out if I needed to. I can take simply Pythagorean theorem. I can take a squared plus b squared equals c squared, and I can figure out this value right here. I'm not looking for that value. I don't need to find that out, but if I wanted it, it was a relatively easy procedure. What I need to do is I need to find this incline angle right here. How much of an incline are these steps going to be rising or falling at? So I have to use a little trigonometry. So there's three methods we can use: sine, cosine, or tangent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Now, I have not established my hypotenuse value. I don't know what that is. I could find it, but I didn't. So because I didn't find it and I don't want to do that extra mathematical step, all I really want to do is I'm going to use my tangent value. So how do I find this out? Tangent equals opposite over adjacent. So here's what it is. This is the angle I want to find. This is the incline angle right here. And I don't know the degrees. I'm going to have a numerical value, so I'm going to look for the inverse tangent. So the inverse tangent equals opposite over adjacent. Inverse tangent, the opposite of this angle is right here. This is the opposite side of that angle. So I take the opposite side, 7.4375, over the adjacent side. There's the angle, and this is the adjacent side to that angle. So I take the adjacent, opposite over adjacent. I do that simple math, divide that out, and I get a value of 0.767741, and so forth. Now, my phone and most people's phone have a scientific calculator. If you don't have a scientific calculator, you have a smartphone, you can use your smartphone. If you turn it sideways, you're going to turn it into a scientific calculator. There's going to be a tangent, a sine, and a cosine button on that scientific calculator. If you hit the second function, and then you'll get to the inverse. You'll get to the inverse tangent. Hit second function, hit the inverse tangent, and we find that our incline angle that we've established with this run and this rise is 37.51 degrees, which falls inside the range, the most comfortable range of 34 to 38 degrees. So I've done all the math. It wasn't that much math to do, but we calculated it all out. We're going to have 9 rises at 7 and 7/16. We're going to have 8 runs at 9 and 11/16. Now all I have to do is take my SPF 2x12s and lay them out. And I'm going to show you that in the next video. So I'll talk to you real soon. Take care. Bye.